Hi everyone and welcome back to NTE. What we have on screen today, right, is a student question, right, and basically what the student would like to know is how to approach these type of questions where you have to find a specific value of k, right. With these type of questions, we all know that when we see this word roots, right, we have to make the connection with that word with the term solutions, right, and usually our mind immediately jumps to the discriminant, right. So if we had the same question, right, so say for example our f of x, right, was actually defined as a parabola, right, so something like x squared minus 4x minus 5, right? If we're asked exactly the same question of saying find the values of k for which f of x, right, equals to k has only what did they say? Let's make it exactly the same as this example, right? So only negative roots, right? Then we know that, okay, eventually what would happen here is that we would have to work with the discriminant, right? The discriminant being, in this case, greater than 0, right? Because we want to actually have roots, right? So if you ignore this extra condition that you have to interpret afterwards, right? If you just read this as f of x is equals to k has roots, right, then you know that the condition you'll be looking for is setting your discriminant greater than 0, right? But then the problem now with this question, right, this specific one, okay, that approach, that whole approach of the discriminant, right, breaks apart in this question, right, because what we have here is not a quadratic, but rather we have a cubic function, right? So my cubic function here can move, right? I can move it, right? And I'm going to use that movement for the second method of trying to solve this, right? So I'm gonna basically show you two different ways that you could have approached this question over here, right? So then basically now start interpreting this question, right? The easiest way to have gone about solving this is realizing the fact that what you have is two equations, right, or two functions that are equals to each other at some point, right? And the other equation, right, is basically a straight line, because if I had to give you an equation, right, if I had to say to you graph y, right, is equals to 2, you would have immediately just drawn a horizontal line, right, through y is equals to 2. Okay, so that's the same thing over here, right? What you have is some unknown function, right, k, right? So you have some unknown horizontal line, y is equals to k, right? Just try it again. Okay, y is equals to k, right? And what you want to know is when is that horizontal line, okay? When is it going to intersect this f of x function, right? And now here comes in the conditions, right? Specifically, you want only, right, to have negative solutions when that intersection occurs, right? So basically, you will then have to bring into this picture over here, right, a horizontal line. Okay, so let's do that, right? Okay, so here is a horizontal line, right? Okay, right, so now let's start thinking, right? Let's put it up at the top over here. Let's put it way at the top. Right. Okay, so if this was our horizontal line, okay, our unknown horizontal line y is equals to k, right? Notice that it is intersecting our f of x function, right? That's the first condition that is met. Very good, right? But then what type of roots do we have, right? And actually in this situation, I would change the word roots, right, to solutions, right? Makes it a little bit easier to think about, okay? What type of solution do we have, right? And where are we going to get the solution? We're going to get it on the x-axis, right? So that's where they meet, right? That point over there. And then the solution is going to be here at that x value, right? You can see currently that is a positive solution, right? And they gave you a condition where you only, right, you only want negative solutions, right? So you know, okay, this is not going to work. It means that this function, right, this horizontal line has to move downwards, right? So let's move it downwards. As it keeps moving downwards, right, it's kind of flimsy, sorry, right? So as we keep moving it downwards, you can see, okay, at this point, I still have solutions, but they're all positive, right? So look at the intersection with the horizontal line and the cubic function, right? And basically trace your eyes downwards to the x-axis, and you can see you have 3, right? At this point, you have 3, right, positive solutions, right? So that's not working, okay? So let's keep moving it downwards, right? Let's keep moving, keep moving. What happens when it's exactly, right, on the x-axis, right? You still have solutions, right, because you're still intersecting the graph twice, right? Specifically at x is equals to 1 and x is equals to 4, right? But is it positive? No, not yet. Sorry, is it negative? Not yet, okay? So let's keep moving. We keep moving, we keep moving. We see now we only have one solution, okay? But is that solution positive or negative? Well, if we trace upwards, okay, there it is. Unfortunately, it's still positive, okay? Right, at this point, you might be feeling quite frustrated and thinking to yourself, well, this is never going to happen, right? So you go, all right, let's just move it extremely downwards. But my graph seems to have finished, right? So that's a little bit of a trick that the examiners use, right? They give you an incomplete sketch of the graph, right? But then you have to complete, right, the sketch of the graph in your mind's eye, right? So if I just move this horizontal line quickly and we carry on sketching this graph going downwards, right? Okay, notice that eventually the graph is going to intersect with the y-axis. Okay, I've erased quite a lot of it now. Okay, so let's just fix here. So I've now fixed basically my y-axis, right? And going back to the equation, right, of f of x, I know that that y-intercept is here at negative 16, right? So if we bring back our horizontal line, right, let's say, for example, it's still over here, right? Then we see that the solution that we have, right, is still a positive solution, right? Because if we map going upwards, right, we still have a positive solution, okay? So let's keep moving until we are exactly on that y-intercept, okay? So when we are on that y-intercept, now all of a sudden we have a solution that is exactly equals to 0, right? That should make you very happy, because you know that once you get to 0, right, if you carry on moving downwards, then your solutions will now start being on this side of the x-axis, right? In other words, they will now start being negative, okay? So let's move it and actually see that happening, okay? So if we keep moving our line, right, let's say, for example, we put it there, right, you can see that the solution that we have now, if you map going upwards, right, it is now a negative solution, okay? If you keep doing that again, right, there's another one, okay? It's still a negative solution, right? Keep moving it downwards, right? It's still a negative solution, right? So when did this actually start happening? When did we actually start having these negative solutions? Well, that happened, or that started happening immediately when we hit this y-intercept, okay? So whenever we choose, right, a k value, right? So if we go back here, right? So there's our equation, okay? Y is equals to k, right? So if we look at the horizontal line the way it is right now, that k value would be a negative, right? So for example, if you had to write the equation of this line, this would be y is equals to negative 16. Okay, so basically then your answer will be, well, whenever we choose k values, right, less than negative 16, right, so less than negative 16, anything going downwards, right, then we will satisfy that condition of when f of x is equals to k, right, we'll only have negative roots. Okay, so then you write down your answer. So what was the difference, right? So the difference is the answer this time didn't come from the discriminant, right, because this is a cubic function, right, so we can't actually use the discriminant, right. The answer came straight from the sketch, right. So then you would just say that, well, in order for us to have this condition met, we have to choose k values, right, which are strictly less than negative 16, right. And we're going to say strictly less than negative 16 because if it's equals to 16, right, then the equation of our line is going to be y is equals to negative 16. Okay, and at that point, right, like that, right, at that point the solution that we'll have is a solution of 0, right, and 0 is neither a positive or a negative number, right, so it's not actually satisfying this condition over here, right. You only want negative solutions, right, so 0 is neither positive or negative, so that's why we exclude, right, this k value, right, so k cannot equal negative 16, but rather k has to be anything less than negative 16, right. Alright, so I promised to show you two different ways that you could have gone about solving this, right? So here's the second option, right? The second option would have been just substitution, right? You would have said, okay, so I already know that f of x is given by this equation, right? So what they want me to do is to set two functions equals to each other, right? So I have to make this equals to some function y is equals to k, right? Okay, so then from here, right, if we just remove this, right, so we don't have a double equal sign, right, this is what we currently have now, right. So from here, obviously you'll just be tempted to just move the k to the other side to give you x cubed, right, minus 9x squared plus 24x minus 16 minus k, right, and that's obviously then going to be equals to 0, right. So then you notice that, all right, so now I have a new function, right, this is my new function, okay, and this new function, right, is going to have different positions, right, and specifically vertical positions, right, because if you look at your k, right, your k is right at the end of the function, right, so it's basically going to be moving the function up and down, right. So why do I say that? Well, it's attached to the original y-intercept of your function, right. So if you pick different k values, right, then you're basically changing the y-intercept, right. So for example, if you pick a k value of say 15, okay, then you'd have negative 16, right, negative 15, right, which is negative 31, right. So then it means that this function, right, would then have a y-intercept at negative 31. So that now makes you aware of the fact that changing this k value, right, is going to change your y-intercept, which basically comes from the fact of this function, right, just moving up and down, right, depending on what k value you have, right. So in the previous method, we had the horizontal line, right, moving up and down. With this method, you have to think of the actual function, right, this function itself, right, moving up and down, Okay, I'm going to just leave it at that original position for now. Okay, so now this is just basically you thinking the solution through, right? So you have to now start thinking, okay, first of all, I have a negative there, right? So you have to be cautious of the fact that must you pick k values that are positive, or must you pick k values that are negative, right? That's the first thing that you have to be a little bit concerned about, right? Because this negative is going to be a problem, right? Let's think for example, if we had to pick positive k values, right? If we had to pick positive k values, then this whole thing, right, negative 16 minus k would be a negative number, right? Like for example, we picked 15 and we got a y-intercept of negative 31. Okay, so we now know that actually choosing positive k values, right, is going to move the graph downwards, right? Okay, so you can imagine this graph, if it actually had to have a y-intercept of negative 31, right, it would be somewhere there. Okay, it would move downwards and be somewhere there. Okay, so let's just analyze this quickly, right? We were trying to make a decision of whether do we want this graph to move downwards, or do we want to have this graph actually move upwards, right? So if the graph moves downwards, right, then does the graph still have roots, right? And now roots in the sense of x-intercepts, right? So let's just write it down, okay? So x-intercepts, roots, solutions, right? So try to be very flexible with moving in between those terms, right? All right, so if the graph moves downwards, right, so at this point where we have this hypothetical y-intercept of negative 31, right, does the graph still have roots, right? Does the graph still have x-intercepts? Well, no, right? You can see the graph doesn't have x-intercepts anymore. Okay, so what about if our k values are negative? Well, if the k values are negative, then we're going to have a double negative, right? We're going to have minus 16 minus something, right? Which is going to be minus 16 plus k, right? All right, so if it is minus 16 plus k, right, then this minus 16 is going to start increasing basically, okay? So the graph is now actually going to start moving upwards. Okay, all right, this is good, right? We're getting somewhere, right? Okay, so now the question is, right, how far upwards, right, does this graph have to move in order for it, okay, to only have negative roots, right? So currently, right, remember we carried on drawing this graph, right, and we know that in its current state, okay, it has a y-intercept of negative 16, okay? So at that state of having a y-intercept of negative 16, okay, it has two positive roots, okay? It has one x-intercept here at 1 and another one here at 4, okay? So if we have a k value, right, this entire distance, right, a k value exactly equals to 16, right, then over here, right, we're going to have negative 16 minus negative 16, right, which is going to be negative 16 plus 16, giving us a y-intercept, right, of 0. Okay, right, so this graph is basically going to move upwards until it has a y-intercept of 0. Okay, so there it is. Trying to get it there. It's kind of flimsy as well, right? So now it has a y-intercept of 0, exactly. Okay, if k is equals to negative 16, okay? Right, so if you go back over here, right, and you put these two things together, right, and notice the fact that, well, a k value of negative 16 achieved to get you to a y-intercept, right, of 0, right, but 0 is, again, is not a negative number, right. So if you put these things together and you say, okay, I don't want basically this k value, right, because that one gives me a root of x is equals to 0, right? So then it means if I exclude this and I combine it, with this inequality above, right, then my answer, sorry, my pens are out of ink, okay, right, then my answer should clearly just be k values less than negative 16, okay? So you're not including that equal sign over there, right? So think about what does that actually mean, okay? So pick a number, right, that's less than negative 16, okay? Let's pick an easy number, right? So something like negative 17, right? If you plug in negative 17 here, right, you have negative 16 plus 17, okay, which basically now gives you an answer of 1, okay, so which means that your new y-intercept, okay, for that function, okay, when k is negative 17, is going to be a y-intercept of 1, okay. Let's say, so I'm not doing this quite accurately, right, but basically this graph would just be moving upwards, not left and right, okay. So if it just moves upwards like that until it gets to a y-intercept of 1, okay, can you see that you now have a x-intercept, right, and that x-intercept is negative, right, which is basically what you wanted, okay. So whenever, right, k is less than negative 16, the graph will move upwards, right, and specifically then what will happen is that the graph will only have negative x-intercepts, right. Let's keep moving it upwards, okay, right. So you won't be able to see it now, right. You have to just keep visualizing it with your eye, okay. You can see that this line on this side, okay, if you carry on drawing it, it's on the negative side, okay, right. So that's one way. Okay, I want to give you another alternative, right? If this whole thinking process of combining these two conditions, right? So combining these two conditions, if that was kind of hard to think through, right? Then you could have, from this point, right, where you got a y-intercept of 0, okay? So from this point, okay, you could have just said, all right, so if I have my graph having a y-intercept of 0, right, and I want the graph to have negative x-intercepts, right, then I recognize that this graph just has to move upwards. In other words, it needs to start having a positive y-intercept. Okay, so you go back to your function, you say, okay, what is determining the y-intercept? Well, this portion right over here, negative 16 minus k is what's determining my y-intercept right now. Okay, it's kind of like the function that's determining my y-intercept. Okay, so I want that y-intercept to be a positive y-intercept. So just set this function, okay, greater than 0, right, because you want it to be positive. Okay, so then negative 16, solving this inequality, okay, is going to be greater than k, right, if you add k to both sides, and this is basically the same thing as just saying k less than negative 16. Okay. Right. Okay, so that's basically how you could have solved this question over here, right? I've now given you a lot of different methods to think about, okay? So I would just keep in mind, right, that first method of just thinking of a horizontal line, y is equals to k, intersecting your function, okay, and then just thinking through, right, where must this horizontal line be, okay, in order for you to satisfy your desired condition. Okay, so this is the method that I would use, okay, and the important thing to note from here, right, is just the fact that we are using different methods, right, so graphical methods and other thinking solutions, right? Because our function is a cubic function, right? It's not a quadratic, right? If it was a quadratic, then you could have easily just solved this, right, by using the discriminant. Okay.